With regards to chromium, we have 2 atoms of chromium in the compound. So if we replace the chromium with X, then we're going to have 2X plus. We said oxygen is always -2, so there are 7 of them. So making -14. Now, when we sum up all these oxidation states, we should be equal to -2. So by calculation, 2x will be equal to 2s minus 14 will equal to -2. So 2x is equal to 12. So what is x? Our x will be 6. So with chromium, the oxidation state is 6. So please check the rest, work them out, and also do the following exercise for me as well. There are works to be done for me. So with this one, let us try the following. Get them for me. Now we have to determine the oxidation states of the underlying compounds. The line 1, 2, the line 1, 3, So work this thing out for me by determining the oxidation state of the underlying compound. Now with the states, just look at this, just assign state to those that are underlined. Now working for all of them. You see that with the thermic acid, you have 2 atoms of the carbon, so you combine them. That's so I think you can do this. Try your hands on this and let's see, move forward. Now the next one is redox balancing. So with regards to that, let us pause and come back. Now let's look at how to identify a redox reaction. Now oxidation reduction always occur together in a chemical reaction. I've told you that you can't find oxidation without reduction. The 2 move together all the time. For this is the reason why we call this redox reaction, or they always move together. Now, the best way to look for or to identify an oxidation reaction is the use of change of oxidation state. That is what we can use. So that when you have a whole reaction, chemical reaction, the best way to determine whether the reaction is redox or not is the use of oxidation state. Whenever there's a change in oxidation state, then you realize that there's redox reaction. But when there's no change within the species, then that reaction isn't an oxidation or redox reaction. Let's see this example. Now you have thin chloride, lead tetrachloride, to give you zinc tetrachloride plus lead chloride or lead dichloride. Now let's look at the various oxidation states. Which is being oxidized? Which is being reduced? Let's look at this. Now you realize that the tin here is in the state of +2. But the tin here is +4. It means that the tin as a reactant has changed to a product here and has increased in state from 2 to +4. in this case, there has been increase in oxidation. So we say oxidation has occurred. So the zinc chloride is being oxidized with regards to the question asked here. Let's look at the lead. Let's look at the lead here. The lead moving from +4 states to +2 states. So there has been a reduction in oxidation number. So we say the lead tetrachloride has been reduced. Now, the one which has been reduced, the entire zinc chloride has oxidized, and the entire this lead tetrachloride has reduced to this. In this case, let's look at this. Abbreviation for that: loss of electron is oxidation. Because the zinc was +2, awesome. Now let's look at an example of an oxidation reaction. Now we have tin chloride plus the lead tetrachloride to produce zinc tetrachloride plus zinc chloride. Now, which is being oxidized? Which is being reduced? You realize that the chlorine has an oxidation state of -1, as indicated. And then the tin has a state of +2. When it comes to the chlorine here, it's still -1. And then the lead is +4. Now, here, let us look at the changes. Now, you realize that the tin has increased in oxidation state. That is from +2 to +4. There has been a change. There has been increase in oxidation state. So with this change, we call oxidation, or has been increased. Now let's look at the lead. Lead, on the other hand, has reduced because it was originally +4 and became +2, so has reduced. So say this is a reduction reaction. Now, when this thing occurs, we say the whole reaction is a redox reaction. Now, when there's no change in oxidation state, such reaction cannot be considered as redox reaction. So here, which is being oxidized? The tin chloride is being oxidized, whereas the lead tetrachloride is being reduced. Which is being oxidized again here. Let's look at this ones. The copper sulfide, hydrogen plus, the nitrite, copper 2, sulfur, the nitrogen dioxide, monoxide, then water. Let's look at the oxidation states. +1, +5, 2, 0, 2, 2. Let's see. Let's see changes. Copper remains 2. Nitrogen has changed from +5 to +2, reduction. sulfur has also increased from -2 to 0. From -2 to 0. So the fact that we have maintained the state of copper does not mean that the reaction is not redox reaction. But at least there have been change in some species that can be used. So in writing this, we can do away with the copper. So copper becomes a spectator ion or species because there has been no change in oxidation state and therefore cannot be included in the reaction. So when we do away with that before we balance it, after balancing, we bring it back to the equation. Now, what is being oxidized? Here you realize that the sulfur from negative state to 0 has been oxidized. And then the nitrogen from +5 to +2 has reduced. That is clearly stated. That is clear to see the changes here. Now, one may ask, why not hydrogen? Why not this? Now, when we talk of changes in oxidation state, we are dealing with the central atoms. What are central atoms? Central atoms, when we do away with oxygen and hydrogen in a compound, the rest, they become central atoms. That is why we dealt with copper, sulfur, and nitrogen. By the end, we realized that copper doesn't change, therefore cannot be included here. But the changes occurred within the sulfur and then the nitrogen. So here the question has been answered. That's clear. Now let us continue with this. Which one is being reduced? This one, which one is being oxidized? Let's look at it. We have already solved this. I think that's a solution to the problem. Yeah. A solution to the problem. Yeah. Now, when we come here, because there has been a change in the 10 from 2 to 4. So we say 10 has oxidized. Then, therefore, the whole of this compound has oxidized. The whole of the 10 chloride has oxidized. But then the lead tetrachloride has reduced. What caused the lead tetrachloride to reduce? It is the zinc chloride. So we say the zinc chloride is a reducing agent. Let's come back here. We say that this one has been reduced. The whole lead tetrachloride has been reduced. Why are we saying it has been reduced? What caused the reduction? You realize that it has moved from +2 to +4 to +2. So there has been a reduction. So in effect, we say that this was oxidized. So what caused the oxidation? It is the lead tetrachloride that caused this to oxidize. So the lead tetrachloride becomes oxidizing agent. So there's a difference between oxidized and oxidizing agents. The one which is oxidized is always the reducing agent, because it will oxidize and go and cause the other species to reduce. So it becomes a reducing agent. And then the one that is reduced becomes an oxidizing agent. Let's have an example, more examples. Well, this has been from 0 state to 3 state has been oxidized. In this case, if it has oxidized, then it becomes a reducing agent. So let us take note of the rest and then continue this. Let's try this. With this one, from +2 state, +3 state, there has Okay. Now let's look at this one too. Let's try this. Here you realize that iron 2 has oxidized from iron 2 to iron 3. So there has been a change in oxidation state. With this, you say has oxidized. Now manganese, on the other hand, has reduced from +7 states to +2 states. Now with this one, we say that the iron 2 has oxidized. Once it has oxidized, then we say it is a reducing agent, because the manganese which has reduced was caused by this. It is the iron 2 that caused the manganese to reduce to manganese 2. So this one is a reducing agent, though it has oxidized. And again, the manganese which has reduced is an oxidizing agent, because the manganese caused the iron 2 to oxidize from iron 2 to iron 3. So we say this is an oxidizing agent. Now let's look at this. 1, 2. The zinc that you see here, the zinc is in the uncombined state. Therefore, the oxidation state is 0. Now from 0, it moved to +2. And therefore, we say zinc has oxidized. Let's look at the hydrogen. The hydrogen, on the other hand, has moved from +1 to to 0. To 0. So we say it has reduced. So in effect, the zinc which has oxidized, this zinc is going to cause the HCl to reduce. So it's going to take the hydrogen to itself, the Cl to itself. So this zinc has reduced, has oxidized, and therefore it's called a reducing agent. Then the HCl, which has reduced, is called an oxidizing agent. Last, now let's look at how best we can balance this reaction. Now let's look at the balancing of redox reaction. The balancing. How to balance redox reaction.